Welcome back, students. We're going to be talking about the characteristics of quadratic functions, especially about what is called an axis of symmetry and using the axis of symmetry to find our vertex and other points. So quadratic functions are symmetric, meaning that there is a line going through the middle of them, going through the vertex, that's that point right there, and both sides of it are the same. You could fold it on top of itself. Now, when we have an equation that's written neatly like that, since we've already been looking at transformations, we can recognize that this is a transformation that's going to go h units to the right and k units up. And so that's going to take us to where the new vertex would be. H to the right, k units up. And then that this also is where the axis of symmetry will be, where x is equal to h. So let's see how we can use this information to quickly draw the graph of a function. So here we have this function. I'm going to quickly draw the parent function of an x squared. So an x squared function is going to look about like that. Now what we can see is happening here with that plus 3, that's going to move it 3 to the left. This plus 4 would move it 4 up. If that doesn't make sense to you, please see the videos on transformations of quadratics. So I'm going to take my vertex and move it 3 to the left and 4 places up. This right here is going to be my axis of symmetry. Oops, needed to be an M. All right, axis of symmetry. Beautifully written. Now that we've got this axis, we know that both sides of this are going to come out the same. So I'm only going to calculate numbers for one side. So let's go ahead and evaluate for f of -2. So f of -2, we'd have -2 times -2 plus 3 squared plus 4. All right, -2 plus 3 is 1. 1 squared is 1. 1 times -2 is -2. Plus 4 is 2. So at -2, it should be up at 2. All right, now this is giving me a new point. Remember, this is symmetric, and here is our line of symmetry. So if I have a point here, I must also have a point right there. Okay, let's do another number. Let's do -1. So -2 times -1 plus 3 squared plus 4. -1 plus 3 is 2, squared is 4, times -2 is -8, plus 4 is -4. So at -1, we should be down at -4. Once again, it's symmetric, so I also know I must have a point right there. So this has been helpful in helping me to identify several points very quickly to create the graph. All right, so what if it's not in that vertex form, as we called it? The vertex form makes it super easy for us to identify the exact location of the vertex. What if it's written in standard form? It might be a bit harder to find the vertex of this. It is a little bit harder, but it's not super harder. So what we have is to find the line of symmetry, it is going to occur at x is equal to negative b over 2a. So we're going to find b and a when it's written in that equation. So a will be in front of x squared, b will be in front of x. And then we can find another point by whenever x is a 0, c will be the y value. Okay, so those are our two pieces of information. Another key piece of information is about A. So notice this one opens upwards, this one opens downwards. The difference is that when it opens upwards, A is a positive number. If it opens downwards, A is going to be a negative number. All right, so let's look at an example of this. We're going to graph this function and label the vertex and the axis of symmetry. So let's start by finding that vertex. Remember, we find the vertex at negative b over 2a. So we want to do x is equal to negative b over 2a. So b in this equation is that value right in front of x. So that's a negative 6. So we're going to have the negative of a negative 6 over 2, and a is the 3. So negative of a negative is a positive. So we got 6 over 6, which is a 1. So we know that our axis of symmetry is where x equals 1. All right, so everything should be symmetric about that. All right, next, we need to figure out where the vertex is. The vertex is going to happen on the axis of symmetry. So I'm going to say I'm finding my vertex here. So I'm going to put 1 into the function. So f of 1 is equal to 3 minus 6 plus 1. And that is going to equal 3 minus 6. It's negative 3 plus 1, negative 2. All right, so at 1, we will be at negative 2, and that will be my vertex. Also, notice the way that the a value, 3, is a positive number. It means it's going to open upwards. So to see that happening, let's get some points. One point that we can easily get is f of 0 because of the way this is written. So if x is a 0, well, 0 times anything is 0. 0 times anything is 0. So that's a 0 minus a 0 plus a 1. So f of 0 is 1, or in other words, just the value of c. All right, so f of 0 is a 1. Once again, this is symmetric, so I know I'm going to have that point on the other side. If I want more points, I can go ahead and put in additional numbers. We could do an f of 3. I imagine these numbers might get pretty big really quickly, but let's go ahead and check this one. So f of 3 will have 9 times 3, 27. 27 minus 18, it's 9 plus 1. Okay. And if that's up at 10, then we know same distance from the line of symmetry. So once you know your line of symmetry, any point you find actually finds you 2 points. Okay, so we labeled our vertex. Oops, nope, we didn't. Always good to reread the directions to make sure that you did everything. We made our graph. We labeled the vertex and the axis of symmetry. Okay, so we finished all of that. All right, let's talk about maximum and minimum values. Once again, we're still in the standard equation. So the y-coordinate of the vertex can be a minimum or a maximum. And so that's what we noticed here. We knew this was opening upwards because A was a positive. So if it's opening upwards, the vertex is going to be a minimum. If it opens downwards, the vertex is going to be a maximum. And it is still happening at b negative b over 2a. So this just lets us quickly identify by looking at an equation. Is this equation going to have a max or a min? This is really good information to have if you're working on optimizing certain problems. It can be good to know if, when you're trying to find the most efficient, if a particular equation is going to contain maximums or minimums. So let's find the minimum or maximum value. So just taking a look at this equation, we're going to peek at A. So A is greater than 0. It's a positive number, meaning this will open upwards. So without even graphing anything, I've been able to identify that, meaning that we will have a minimum in this graph. All right, so that's pretty good. We haven't done any difficult math, and we've been able to identify all these different things about it. We can also identify, let's see, it wants the domain and range of the function and where it will be increasing and decreasing. Okay, so domain and range, those are going to be, well, domain will be easy. Domain, you'll notice for either of these, it's just all real numbers. You can put any number in for x, and this is going to be able to do it. So let's go ahead and put domain. I'm just going to say all real. Range gets a bit trickier. So range is all the possible y values. Now notice here with range of this one that opens up, it is all the values bigger than the minimum. So we need to know what number is the minimum to be able to say what the range is. When it goes downwards, it's all the y values that are less than that minimum value. So now in order to proceed with this problem, we got to figure out where our axis of symmetry is and then find that minimum value that we have. So let's do that now. So x is going to equal to negative b over 2a. B value is a negative 2, and a was a half. Negative of a negative will be a positive, so that'll be a 2 over 1, which is just 2. Okay, so we now know this is where the axis is. I need to know where the actual minimum was, though. So we're going to put this value 2 into our equation. So f of 2 is going to equal 1/2 of 2 squared minus 2 times 2 minus 1. So it'll be 4. Half of 4 is 2 minus 4 minus 1. Okay, so we know that the vertex happens at 2, negative 3. Whoa, what just... So our vertex is at 2, negative 3. This also happens to be the minimum. Great, just randomly disappearing stuff. All right, but that does give us our range. Our range is going to be, since that's a minimum, it'll be all the numbers greater than a negative 3. So we got domain, range. Now we need to talk about where it's increasing and decreasing. So if this is some equation that is opening upwards, okay, and then it's right there at 2 at its minimum. Notice as we go forward, it's going... Sorry, I do not know why it's glitching so much. It's going forward and down, but then after the 2, going forward and up. So the way we're going to talk about increasing and decreasing, so it's increasing from where x is greater than negative infinity all the way up until 2. Okay? And then that's where it's decreasing. So from negative infinity all the way till it reaches 2, it is decreasing along there. And then it's going to be increasing starting at the 2 and then going towards infinity. Okay, and there are other ways of writing that. They gave their way right there. We can use interval notation and put this as 2, comma, infinity. What's most important is this understanding of if it has a minimum, I know everything to the left is going to be decreasing, everything to the right is increasing. And then vice versa for maximums. Okay, I hope this helps. Good luck on your practice.